Welcome dear students to a very new interesting topic that till now you can see that we have learned how to draw a schematic when the schematic is very small or your circuit is not complex. So let's first of all launch our KiCad application by double clicking on this. This is the front interface. So let's just make our project by going to file, new project, and let's choose the desktop, and let me say it design for complex schematic, and hit save. Now you can see that we have just created our project. In all the previous videos and the sections, we have seen that we have designed our schematic over a single page. Let me show you our schematic editor. This was our schematic editor where we have designed our schematic in a single sheet. But what if we have a schematic that is complex and that has a number of components and do not fit all those components in a single sheet? Then there are two methods. Either you can increase the size of your sheet by going to file and page setup, and over here you can increase the size of your sheet so that your schematic can fit into your drawing sheet. Another thing is you can add multiple sheets in your schematic. Like this is the one sheet. On the left side you see over here it says root page 1, which is this sheet which you are currently seeing in your canvas. Now if you have the schematic that is not fitting into this sheet, we can add an other sheet to add the rest of your schematic into that sheet. In order to add another sheet, on the right side over here you see this add a hierarchical sheet tool. Click on this tool and click anywhere on this sheet and draw a sheet by clicking again on this sheet, and this dialog will open up, and you have to name the sheet. Let's say I want to draw the circuit in this subsheet by that is related to some power section. Similarly, let me change the name of the sheet file to power and hit OK. Now on the left side you see that we have a subsheet with the name power, which is under the parent sheet, that is root. The sheet you are currently seeing on your screen is the root sheet or the parent sheet, while the sheet we have just added over here this little box, that is called the hierarchical sheet symbol. This sheet we have added is the subsheet of our parent sheet, and over here this root one is the parent sheet and this power is the subsheet. There are two ways to enter into this sheet. Let me go to parent sheet. By clicking on the sheet you enter into that sheet. By click on this is our parent sheet. If I click on the power, that is our subsheet, you can draw a circuit that is related to power section of your schematic. The other method is, let's go to root sheet, and on here either you double click on it and you will enter into that subsheet. And another method to enter into sheet is click on this, right click over here, and over here you see a option that says over here you see an option that says enter sheet, and then clicking on that you will enter into that subsheet. Let's say if I have another a section of the schematic of your electronic circuit that is related to microcontrollers, then I can add another sheet into our root sheet by clicking over here, add hierarchical sheet, or click S. So click on this sheet and draw another hierarchical sheet symbol, and over here I can write the name of the sheet like it's related to microcontroller. I can say MCUs, and I can also change the name of the sheet file as MCU and hit OK. Now I have added another hierarchical sheet symbol and added another sheet in my schematic. That is on the left side. You can see that we have this page 3 that is related to MCU. Simply by clicking on this, we can enter into the sheet that we have currently added in our root sheet. So currently we can see in our root sheet we have two subsheets that are, one is power sheet, the other is MCU. What if I want to add another sheet into my subsheets? Let's say I want to add some section that is related to some regulators in the power section. So go into this power sheet and over here draw an other hierarchical sheet, and let's say this sheet will have the circuit that is related to regulators, and let's change the sheet file name to regulator and hit OK. Now you can see on the left side that we have a parent sheet that is root, which have two sheets of power and MCU, while the power subsheet has an other subsheet that is with the name of regulator. So currently we have 4 sheets in our schematic with one root sheets, two subsheets, and another subsheet with the name regulator that is subsheet of the parent sheet of power. So in this way you can add multiple sheets into your schematic. So if you want to navigate through this sheet, you can like if I go over here, simply you can double click over here and enter into this sheet. Again click on this regulator hierarchical sheet symbol and you can enter into the regulator schematic sheet. Another way to identify in which sheet you are currently present is you can see over here in this title block it says that regulator dot keycad underscore schematic extension, which means that we are in a currently regulator sheet. Another thing is over here you see that sheet, it says power then regulator, which means it has a parent sheet with the name power and it is a subsheet with the name regulator. Similarly, this is our root sheet, and if I go to MCU, it will say that after root sheet we have this sheet that is with the name MCU. You can also use these arrows to move through your sheets. By clicking on these arrows you can navigate your hierarchical sheets. So in this way you extend your number of sheets in your schematic and by using this tool, that is add a hierarchical sheet tool, or simply click let's say if I click on S on the keyboard and it will add an other sheet over here, and let's say if its sheet is let's name it as indications, and click over here indications and hit OK. Now I have added another sheet with the name indication by using S on our keyboard. Now, dear students, we have seen that how we can increase the number of sheets in our KiCad schematic, and we have seen that we have added parent sheet and as well as root sheet in our schematic. Now it's time to see that how we can link our all the sheets with one another. As you know that a complete schematic has all the components linked with one another. Like let me tell you, if we have a sheet that has a power section, and in the power section you can have indicators and regulators, as well as in the schematic you also have something that is related to MCUs. Now we need to power up the MCU, so which means that the output of this schematic, like the power out of the circuit we draw in our power section, will also be connected to the MCU. That, as well as you know that MCU needs some power to execute the code that we have just added in our MCUs. So in order to link all these sheets in this schematic with one another, we use or the KiCad gives us the facility to add labels. There are three types of label which we will be using in our hierarchical schematics. On the right side you see that over here this is a label which is named with the add net label. This type of label makes connection within the sheet, and this is also called local label. So let me just name it as local label, and these are all its settings, like its font, its orientation, text size and color, and let's just hit OK. These are called local label. Let me just zoom in, click and move a little above. So these are local label, and this makes only connection within a sheet. So local labels cannot be used to connect between the sheets. So let me just write over here some text so that we can make a comparison between all the labels. So this local label makes a connection within the sheets, and let's just hit OK. And this is the property of our local label, that it makes only connection within the sheet. Mean to say that if this local label is used on this sheet, the root sheet, it will only be connected with the it will only make connection within this sheet. The next thing, the next label we will be using is this one, the global label. Let me click on this and let's name it as global label. Over here you can even change the its shape from input, output, bidirectional, tri-state or passive, and even you can also indicate the side where this will be connected to the net. So let's just hit OK, and you can see over here that this is our global label. And global label, let me add some text over here, and these global labels make connection anywhere in a schematic regardless of the sheet they are added. Global label makes connection anywhere in the schematic, and let me hit OK and place over, which means that if I have used my global label on this root sheet and I have used the same global label on my, let's say, regulator sheet, on this regulator sheet, then this global label, as it the name of the label is same, so a connection will be made between the regulator sheet and the root sheet circuit. So the global label makes connection anywhere in the schematic. The next label, which is very useful while designing the hierarchical sheet, is the hierarchical label. So let me just write its name as hierarchical label. And even you can change its shape from input, output, bidirectional, tri-state, and passive, and change its orientation as well as color. Let's just make it capital. So this is the hierarchical label which is used in our hierarchical schematics. And these hierarchical labels connect to hierarchical sheet pins, and hierarchical design relies on hierarchical labels and pins to make connection between parent sheet and the child sheet. You can think of hierarchical pins as defining the interface for a sheet. So over here, it actually, you can say, it acts as an interface between the hierarchical sheets and hit OK, and let's place over here. So these are the three types of labels that we will be using in our hierarchical sheets to add connections between all the sheets. So just to sum up, you can see over here we have a local label that only connects the circuit over the sheet in which it is used. The next is global label. You can connect the circuit anywhere in the sheets of your schematic, and this is the hierarchical label which we will be using to connect our hierarchical sheets with one another. So these labels help us to complete our complex circuit while designing the circuit in multiple sheets. Another thing is, you can even click on this and hit E to edit its properties. And similarly, let's say if I want to edit the properties of global label, hit E, and let's just change it to bidirectional. You can see that its shape will change. Let's click on this, hit E, and let's say it's an output, and hit OK. Its shape will change. Similarly, you can do this with the hierarchical label. Click and hit E, and let's say it's a bidirectional label, and click on this, and you can see over here that our symbol of this hierarchical label has changed. Now let's click on this, and let's say it's an input, and hit OK. You can see our label shape has now changed. So now in this video we have seen different types of label, and we will be using in the coming videos. Now till now we have just discussed different types of labels. One thing more to add to the topic of labels is that labels that have same name will connect regardless of the label type if they are in the same sheet, which means that if we use all these three labels and they have the same name, then they will be connected with one another if they are used on the same sheet. So let's just let me prove this claim. Let's just add this microcontroller Arduino Uno R3 over here, and let's just add first of all this local label or the net label, and let me just write a simple name. Let's say its name is A, and hit OK. Let me just place over here, and let's just add now a global label, and let's name it as A, and hit OK. And let's just place over here. Let's add now a hierarchical label and also name it as A, and hit OK and place over here. Now you can see that we have added three different types of labels. We have added three different types of labels: the local label, global label, and the hierarchical label. Now let's just make a net by connecting a wire between this pin number 9 to this local label, and add another wire between pin number 10 and to this global label. Let me just change the setting of the wire by going over here, and now let's click on this and join with this global label, and let's just add pin number 12, connect pin number 12 with this hierarchical label. Now you can see that we have used three different types of labels in a single sheet, that is our root sheet. And now let's check if all these pins 9, 10 and 12 are connected with one another. So in order to highlight the net, the schematic editor has a tool over here, that is the highlight wires and pins of the net. Click on this, and this once you click on any wire or a pin, this will highlight all entire net, and all the pins that are connected in that net. So let's just click on this. You can see over here that the color of the wires, the labels and the pins have changed, which means that these all three pins are connected with one another using these labels, and these labels are connected with one another because we have used the same name of all the three labels. So let me just change the name. Let's say let me edit this label, the local label, and change it from A to B and hit OK. Now let's check that either it is connected with the rest of pin number 10 and 12 or not. Click on this highlight wire, click on this net. You can see that the pin number 10 and 12 didn't get highlighted because we have a label with a different name. Similarly, if I click on this, you can see that 10 and 12 pins are connected with one another using the global label and the hierarchical label. So make sure to give unique names to the labels that you do not want to connect with one another. If you give the same name to the labels of any type of any of these three types, if you give the same name to any of these three types, those labels will connect with one another regardless of their type. Now dear students, till now we have discussed the different types of labels and as well as have discussed the scope of the labels. Now just let's build a very minimalistic schematic so that we can understand in a better way about the hierarchical sheet system in our KiCad software. So in order to understand this concept, the first thing we need to do is let's just build up a schematic that takes 12 volt as input and converts into 5 volt, also gives 5 volt out to some other peripherals, as well as also power up the MCU with that 5 volt, and should have some indications of the 5 volt power supply as well as an indication from the MCU. So first of all, let's just add a 2-pin connector over here. Let me write a connector. Let's say I want to add a connector that is 2-pin, that is 1x2, and let's just double click it and let me place over here. This is the connector where we will get 12 volt input, and just let me write some text over here that we will connect over here 12 volt from the outward from the that we will feed 12 volt into our circuit from these two pins. And let's just add an other connector 1x2, which means it has a single row and two pins, and place it over here, and over here we will get 5-volt out that is generated by the power section. So let's just save our work. Now after we take power from the 12-volt input, we will feed this power into our this power section. In the power section we will be using regulators to regulate this 12-volt input. So let's go to regulator section. We on the left side you can see that we are in the regulator sheet, and let me just add over here regulator 7805. Let's just double click it and place it over here, and let's just add capacitors this unpolarized capacitor over here. Add another one, click insert on your board and add another one, and let's just wire it up by clicking on the add wire tool, and place over here. Let's just add ground, the schematic. I just place over here, click insert, place another one, insert, place another one. Let's just wire it up, wire this up over here, and let's connect this one. Let's just save our work. Now you can see that this is just a simple 7805 regulator circuit. Now the next thing is we will add a hierarchical label over here, and let's just name it as 12-volt in, which means 12-volt input, and let's hit OK, and let's place over here, click R to rotate it, and let me place over here. Similarly, let's add another hierarchical label, click on this sheet, and it will generate 5-volt out, so I will write 5-volt output and hit OK. As you see that this is our output, so let's just click over this output, and this will change its shape. So let's just place over, let me just place over to make it little beautiful. Click over here and add. Now you can see that we have added two hierarchical labels, 12-volt in and 5-volt output, in our regulator sheet. Now the next thing is let's add something in the we are currently in the power. The power is the parent sheet, and we have drawn circuit in our regulator subsheet, and let's just add some circuit in our indications. So in our indications, let's just add some resistor over here, this resistor, and add an other resistor so that we can add two LEDs, one for indicating that we have a 5-volt available in our circuit, and the other should be connected with the pin of the MCU. So just add an LED. Let's click R, place it over here, and place it over here. Again click insert and hit R to add an other LED, and let's just make connection with these. Let's just place and drag over here. Let's add another wire over here, and let's add ground to both these. Place over here, click insert, add ground, wire it up, No, I accidentally clicked on the canvas. Just click on this circle, click and make a connection. Similarly, let's click on this and make a connection. So now we have added two resistors with the LEDs. So what next thing is we want to do is just add an hierarchical label over here. Let's just add this is for the 5-volt IND, which means indication, 5-volt indication that we have 5-volt available in our, and let's just place it over here. Click on this, hit E, and let's change it to input. Click OK. Let's just rotate it and let's connect this with this one. Similarly, add another hierarchical label, and we want to connect this with the let's just add a global label over here. Let's see what happens if we add a global label. Let's click on this, and let me use over here as MCU LED, and it is input to this. We will connect this in the we will be using this global label in the MCU circuit. So place it over here. Let's wire it up and connect with this. Now we have added in this indication circuit 5-volt IND hierarchical label and global label with the name MCU LED. And let's just save our work. Now we have what we have now. In the root section we have this 12-volt input. In the power we have added some indications in this regulator. We have added a regulator circuit in the regulator sheet, and some indications in the indication sheet. So the next thing is we need to add a microcontroller in our MCU sheet. So let's just click over here and let's add I want to use Arduino Uno R3. Double click over here and let's just place it over here, and you can see that let's just add ground, place it over here, and let me wire this and connect all this ground with this one. Oh, I accidentally placed somewhere else. And now we have connected all these grounds. Now what we need to do, we want to use let's say this pin number 9. Click over here and let me do this. Click over here, double click, and a wire is now connected with the pin number 9. We want to use that we want to use this pin number 9 so that we can switch on and off an LED. That LED we have placed in our indication sheet with the label MCU LED. So let's just copy this label, go to MCU, and let's paste it, and let's place it over here, and let's just click over here, hit M to move and connect with this. Now you can see that we have added a global label over here in the MCU sheet with the name MCU LED, and have added indications with the MCU LED global label in this indication sheet. So let's check if we have used global label over here and have used global label in the MCU sheet, and we have also claimed that the scope of global label makes connection anywhere in the schematic. So you can see that one global label is under the with the in the subsheet MCU, and it has a parent sheet root. Another global label is in the indication with the parent sheet as power. So let's see if these are connected with one another. Go to this highlight tool and click over here. Now its color has changed. Let's see in the MCU sheet that our global label is connected with the our circuit is complete or not. And you can see over here that the color of this pin number 9 has also changed, which means when I highlighted this net, then this pin number 9 of the MCU in the MCU sheet is now connected with this LED D502 circuit in the indication sheet. So we have seen that global labels make connection anywhere in the schematic. So these are the global labels that so the global label helps to make connection anywhere in the schematic. So the next thing is let's add a hierarchical label over here, and let's just name it as MCU 5 volt, and click over here, and let's just place it over here, and let's just add wire and connect to MCU 5 volt. Now in the on the microcontroller side we have used global label and a hierarchical label, and let's just save our work. And on the regulator side we have used these hierarchical labels. In the indication side we have used a single hierarchical label and an MCU LED global label, and we still need to connect these sheets with one another, and also need to connect these sheets with one another. So in the next video we will be seeing how we can import these hierarchical pins in our schematic sheet symbol and connect this with one another. Dear students, till now we have drawn our schematic in a section wise approach, which means that on the left side you can see these are all the sheets that we have added in our schematic, and in each sheet we have added a circuit. Like if you go to power sheet, we have added two other sheets like indication and the regulator. If we enter into indication sheet, we have these two LEDs, and if we go towards the regulator side, the regulator sheet, then we have this regulator in this sheet. And if we check this subsheet MCU, then we have used Arduino Uno as for our study purpose. Now it's time to connect all these sheets with one another so that the entire sheets join to form a complete schematic. In order to do that, let's go to the root sheet, and in the power sheet over here you see that in the regular sheet we have used two hierarchical labels, 5 volt output and 12 volt input. The first thing we need is to import these hierarchical labels over here in this regulator subsheet symbol. This is the regulator subsheet symbol. In order to import the hierarchical label we have used in this sheet over here in the symbol, we use a tool on the right side over here. It says import hierarchical sheet pins. So click over here and then click on the sheet in which you want to import those labels. So I want to import the hierarchical labels of the regulator sheet. Then just click over here and you can see we have used 5 volt output hierarchical label in the regulator sheet, and that label is now imported in this symbol. So you can you have to connect this on the outer boundaries of this symbol. So let's just click over here, and it will then pick the next label that we have used, that is 12 volt V in hierarchical label in the regulator sheet. So let's just click over here, and it says no new hierarchical label found, as we have used two hierarchical labels in the regulator sheet, and we have imported those labels in this regulator sheet subsheet symbol. Similarly, let's import hierarchical labels of the indication sheet. For doing that, again go over here on this import hierarchical label hierarchical sheet pins, click over here and click in this sheet, as it has this 5 volt indication hierarchical label. So just click over here, and it has only a single hierarchical label. That is why it didn't pick the any other hierarchical label. And the second label we have used in this, it was a global label, which we have already discussed its connection with the MCU. So let's go to power sheet. Now you can see that we have imported the hierarchical pins from the regulator sheet as well as from the indication sheet. Now it's time that this 5 volt V output should be connected with this indication LED, or in the other word you can say that this regulator pin out, pin number 3, should be connected with this indication LED. So the next step is over here in the power sheet. Let's just select it, move, and let's place it over here. Now for doing that, first of all let me show you that this is the regulator sheet. Let's highlight this net, click over here, and I want to connect this with this one. As you can see that this didn't get highlighted, as it is not connected with the pin in regulator. So let's go to power over here. In the power sheet, let's just wire these two sheets together. Over here, this is the 5 volt output from the regulator sheet. Let's connect to the 5 volt indication. Now the output of regulator is now connected with the indication LEDs. So let's just save it, and let me show you by using the net highlight tool. Click over here, and let's click over here, and let's check this in indication. You can see that its color has changed, which means that this resistor and LED circuit is now connected with this regulator, and these both sheets, the indication sheet and the regulator sheet circuit of this 5 volt, is connected using these hierarchical pins of the regulator 5 volt output and the hierarchical pin 5 volt IND from the indication, and both sheets are joined using this wire. So in this way we connect the hierarchical pins with the other hierarchical pins in another sheet. Similarly, you can see over here that we have a 12 volt. Similarly, let's go towards the root sheet. What we next want to do is we want to connect this 12 volt. Let's say we will have, let me just connect ground over here, and a ground over here, and let's just wire this up with this one and with this one. So if the 12 volts are applied to pin number 1, they should go to this power pin. So let's import hierarchical labels from the power pin. This will give us that there are no labels, because let me just show you. Click over here on import hierarchical pins and click over. It says no new hierarchical label found, because we have not used any hierarchical label over here. So for using the hierarchical labels over here, what we need to do is let's just place this hierarchical label and let's name it from 12 volt DC and click OK, and let's just rotate it and place over here, and let's wire this hierarchical label with this 12 volt in, which is to the input of regulator, 5 volt regulator. Let's just save this. Similarly, go to root sheet. Now if I click over import hierarchical pins and click over here, this will give me this label 12 volt DC label, which we have just used in our power sheet. So let's just click over here and let's just wire this up. Click over here and let's join this with this one. Now you can see that 12 volt from the pin number 1 is connected to the power regulator sheet, and in the power regulator sheet 12 volt is connected towards the regulator sheet, and in regulator sheet it is connected to 7805. You can check this by using highlight tool. Click over here, let's highlight this net, go to root sheet. You see it is now highlighted, this one is highlighted, this one is highlighted, which means our 12 volt from the input connector of the schematic is now fed to the regulator 7805. Similarly, let's import the hierarchical pins from the MCU. Right click on this, and you can also use this import sheet pins, and you can see over here it says MCU 5 volt pin, which we have used in the MCU subsheet. So let's double click it. You can see we have used one global label, and this one is the hierarchical pin which we have used in the MCU, which is now imported into our root sheet. Now the next thing is that we want to give 5 volt to this MCU, and the 5 volt was generated in the power sheet in this regulator sheet. So this 5 volt are have reached over here and are given to indication sheet, but we need to feed this 5 volt to the MCU sheet also. For doing that, let's use another hierarchical label, and let's say MCU 5 volt. You can give any name depending upon your convenience. So let's just click OK, and let's just place it over here. Let's just change its symbol and say it as it is out and is fed to the MCU. So let's just wire this up, click over here and join over here, and now we have used another hierarchical label in our power sheet. So let's go to root sheet and let's import the remaining 5 volt hierarchical label over here. Now till now, if I highlight the MCU 5 volt, this one pin, as it is not connected anywhere, you will see that this label is only highlighted. If you go into power side, no 5 volt net is not highlighted. So in order to make a connection, we need to do is we need to connect this MCU 5 volt from the regulator or from the power section of the schematic to the MCU 5 volt. So let's just wire it up, click over here, and let's just click over here. Now let's save our work, let's highlight this and see if 5 volt is applied to MCU or not. Let's go to MCU. You can see it's now highlighted, which means 5 volt is connected to MCU. If we go towards the indication, 5 volt is connected with the indication circuitry. We go to regulator, it's connected with the regulator. In the power section, we have the indication and the regulator sheet circuit is now complete. Now the next thing is we have to also give this 5 volt for to this connector also. So let's just use local label. As we have discussed hierarchical labels, global labels, let's just use a local label. For using a local label, we have to use this add a net label. Click over here and let's give 5 volt local and hit OK and just place it over here, and let's just wire it up, and let's just make a copy of this 5 volt and let's just place it over here on this wire and save it. Now let's see if 5 volt are now connected using local label. Click on this. Now you can see that this 5 volt this pin number 1 is connected with this 5 volt using the local label. So what we have done is we have first of all used global label, this one global label, which means that they are connected, they makes connection anywhere in the schematic regardless of either it's root sheet or parent sheet or subsheet. It makes connection regardless of these constraints. But if we use hierarchical labels like this one, then what we need to do is we need to import these labels in our subsheet labels, subsheet symbol. This is our subsheet symbol. We need to import these hierarchical labels. Like in regulators we have imported these two hierarchical labels. In indication we have imported these hierarchical labels. After importing the hierarchical labels, then we need to make a connections between the subsheets using wires. You can even use labels on these wires as well. So in the root sheet we have also used the local label 5 volt, which makes connection over the in the sheet in which it is used. Let's say if I copy this 5 volt local label and go to MCU and let's just paste it over here, and I just place it over here, and let's make a wire connection with this. And if I highlight this, and you can see it is only highlighted over here, but if let me highlight again, and if we go I go to root sheet, you can see these are not highlighted because we have these labels are local labels and they are only confined to the sheet in which these are used, like over here. But if I again copy and paste, and let's just for the sake of understanding I connect over here. You can see it is now highlighted like this one. So as you can see this local label has the same name as that we have used over here, but they are used in a different sheets, so they are not connected with one another. So we have seen that how we design our complex schematic having multiple sheets, how we use hierarchical labels, what is the scope of all these three type of label: local label, global label, and hierarchical label, how we import them in the schematic symbol, and how we make connection with one another, are the connections, how we make connections between the sheet symbols. Now dear students, till now we have drawn our schematic using multiple sheets and have connected these sheet symbols with one another using their hierarchical pin labels as we have seen in our previous videos. And now it's time to move further, like we have just done in our previous sections while studying the schematic, drawing the schematic in the schematic editor. we perform a thing that is called electrical rule checker. So similarly, while designing the schematic using multiple sheets, we also perform the electrical rule check over here. So let's just perform electrical rule check over here, and let's run ERC. Now it has indicated us 33 errors and one warning. And let's just solve these errors and warning one by one. The first, it says label not connected to anything. Just click over here and see. It says that these labels are not connected to anywhere, as I have just used these labels for our understanding purpose. And let me just delete this, and let's just delete this one also. Let's just also delete this label as well as this local label. And let's say if our error reduces, let's run ERC, and yes, our these three errors have been now removed. The next thing is, it says input power pin not driven by output power pin. Let's check where this error is. I think it's in the MCU side, and it has indicated us over here in the ground side as this error we have. This type of error we have also encountered in our previous videos, where we remove this error by using power flag. So let's just click over here, double click it, let's just rotate it and place it over in this net, and let's again run ERC, and you can see now that this error has been now removed. Let's just I just accidentally pressed escape, perform ERC, run ERC, and the next thing, it's a warning. We will deal with warning at end. Let's just uncheck it, and it says pin not connected. Which pin is not connected? Over here, these are list of all the pins we need to place are not connected symbol over here, and then most of the errors is removed. So let's just place over here one by one. Let's place over here. As you can see, these pins are not used currently in our design. I have just drawn a very simple design just to make you understand about how hierarchical sheets work. Let's just place all over the pins that are not connected. Let's just place it over here. Let's just place it over here. Over here, I just made a mistake. Let me first of all correct this. That this pin should be connected to 5 volt, and let's just delete this wire and place this no connection flag over here. And we have almost placed the not connected flags on the pins of MCU. So let's just run ERC again, run ERC, and now we are left with only one warning. And let's see which with the one error, and it says over here that input power pin not driven by a similar error. We need to place a power flag over here. Let's just place over here, and let's run ERC. Now we have no errors, and let's check which type of warning it is saying us. It says warning label, hierarchical label, MCU 5 volt, MCU 5 volt. It says that the label name is same, only there is uppercase and lowercase difference. So let's just see where these are. It says MCU 5 volt, and the other is over here. Let's just change this one to something else, and let's change MCU 5 volt VDC and hit OK, and let's go to root sheet in order to, as now this is now changed, let's import sheet pins. This is the pins, and let's delete this label, and place this label over here. Now this is connected to this one. Let's just save this. Let's check if our warning has been now removed. Run ERC, and now we are left with no errors and no warning. So while designing your schematic in multiple sheets, the electrical rule checker performs in the same way, checking for errors and warnings. Till now we have drawn our schematic in a hierarchical sheet. Now we have even also performed our electrical rule checks and have removed errors in our schematic. Similarly, we can also assign footprints to our components in our sheet. In the similar way we have already studied. Over here, go to bulk edit field, click on this, and let's just add footprint over here. Click on this, and let's choose footprints from the footprint library. Over here you can see you can write over here capacitors. Let's see, we want to choose SMD, and in SMD let's just choose this package 2012. Let's double click it, add over here. Let's add footprint for C402, and I want to choose this one. Double click and add. For LED, I want to choose an SMD LED for this one. LED SMD. Let's choose with the let's choose 1206 package. Let's double click it. Similarly, 1206 package for this one. Double click it, and now it's done for the connectors. Let me choose connector pins with the header with 2.54 mm pin pitch, and let's choose these horizontals. Double click it, and similarly let's add connector to J102. Double click, and let's add resistance. Let's add 1206 package for resistance, and it is 1210 1206 hand soldered. And let's just add for this one. Now it's a turn for regulator to add. Let's choose TO packages over here. TO through hole and TO 220, where it is 220, and that is this one, TO 220-3 vertical, and this is the 4 pin. Let's say for the sake of simplicity, let's just add this one and double click it. Now we have added all our packages over here. Let's click OK, and let's save our work. And now after adding the packages, we can open PCB editor and import all these settings, the footprints from the schematic into our PCB. And let's now click over here, update PCB changes made to schematic. Click over here, we have no errors, no warning, and update PCB and close. You can see that we have all the components that we have assigned in the schematic. So place it over here by clicking it over here. Similarly, you can see this in 3D viewer. So these are all the components we have used in the schematic. So the basic purpose of all this discussion is that we design schematic in a multi-sheet way, where we use multiple sheets, and we can do all the things we have already stated previously, that we can even perform electrical rule checker, we can assign footprints, we can design PCB from this schematic, exactly the same way as we have done for a single sheet. So till now what we have learned is that how to design a schematic when there are a large number of components used. Then we divide our schematic in in different sections, like there is some power section, like indication sections, like there are some controller sections. You can even if there are sensors in your circuit design, then you can make a sheet where you will wire up all the sensors, will draw the wires of all the sensors. So how large your schematic is, you can easily draw your schematic while using this multi-sheet approach in KiCad. Now dear students, the schematic you are just seeing, I have just designed it for my client, and you can see over here that it's a hierarchical schematic, which means that it have a root sheet, and there are bunch of subsheets. And in the root sheet, you can see over here this is subsheet symbol, this one is subsheet, this is subsheet, and this one is subsheet, this is subsheet. So these are all the subsheets, and over here you can see that this hierarchical pin is from the subsheet SN-S01 is connected to this hierarchical sheet symbol using this hierarchical pin. So this is the hierarchical pins we have used, and you can even let's say if I double click over here, this will take us to the SNS00 sheet, and this is a schematic or the section of that particular circuit we have drawn in this sheet SNS00. Similarly, these are all the sheets that we have added in our root sheet, and this is the switched output is the sheet that is added to the root sheet, while switched output has subsheets with the name switched 0, 1, 2, 3 and 4. And over here you can see that this is our symbol of our hierarchical, this is hierarchical sheet symbol. Similarly, this is on this one, these are the four hierarchical sheet symbols or four hierarchical sheets added into the parent sheet named as switched output. Similarly, double click on this, you will see the circuit that is designed in this particular subsheet. Similarly, these are the mounting holes that are used that will be used in the PCB that we have just added in a single sheet. And these are all the that are related to indications, and this sheet is related to MCU. So it depends upon you how you organize your schematic, in which way you organize your schematic, how many number of sheets you want to use, how many sections you want to create, and how you connect these sheets with one another. You can even use global labels, you can use hierarchical labels, and I think there might be some net label, local label used. You can use them as per your the way you want to organize your schematic. So this was just an example. I just thought I can show you this example, this practical example, where you can see that we have at least 1, 2, 3, 4, 5, 6, 7 and 3, 10, 11 and 3, 14 At least we have 14 sheets in our schematic. So the hierarchical sheets are the hierarchical the schematic hierarchy helps us to draw a larger or a complex circuit in KiCad. Now dear students, today we are going to discuss how we can organize your schematic using bus wires, or in another way we will learn today how to use bus wires. So first of all, let's create our project. I want to save it on my desktop and let's say bus wire. Let's name the project as bus wire and click save. And let's go to buswire KiCad schematic. This is a schematic sheet we have already learned. We have also learned the tools on this top bar, on this left bar, on this right bar. Now the one thing that is left is this one, the add bus and the add a wire to bus entry. Why we use this? First of all, let me show you. Let's just add a microcontroller Arduino. Let's double click it and place it over here, and let's just make a simple circuit that I want to connect this the pins of this Arduino to some header. Let's just place a header over here. Let's say it we want to use connector, let's say I want to use 1x15 header. Let's just double click it and let's just rotate and place it over here. Now one way is what I do is I just go to add wire tool and start to route the connections between these pins toward this, like this. Let me just show you. Click on this and let's add to this one. Similarly, D1 I want to connect it with pin number 2, and this way. Similarly, pin D2 and to pin number 3 and pin number 4 to pin number 18, D4 to and 5, and if I keep on adding, you are seeing that we have encountered a problem that there are number of wires that are going from this side towards this side, and you can also see over here that accidentally we have connected pin number 1 and pin number 5. Now an alternative way is to use bus wires that will help us to organize this schematic. That is, let's just remove all these wires by Control Z, and first of all let's add a wire over here, a small piece of wire over here, and you can hit insert and it will add wires to other connectors as well. Similarly, let's just add wires, a piece of wire over here, and hit insert on your keyboard. This will add wires with the pins. Let's also just connect this one over here and hit insert, and this is, let's just delete this and let's save our work. Now the next thing is we have to use this add to bus wire entry. Let's just rotate it, place it over here and hit insert on your keyboard. This will add the add to bus wire entry, this thing. Similarly, let's just place it over here and hit insert. This will add to the remaining pins. Let's just rotate this and let's click over here and hit insert. This will add the add to bus wire entry. Let's just delete this extra. Now the next step is we have to draw bus wire. Over here you can see that this is our add bus wire tool. What I am going to do is I want to connect this A0, A1, 2, 3, 4, 5 to the pin number 15, 14, 13 and 11. So what I do is I simply click over here, click like this, click on this, click over here. Let's just join all these and then move up over here and let's connect these 15, 14, how many these are, 3, 3, 6 and 2, 3, 5 and one more over here. Now you can see that I have connected pin number A 0, 1, 2, 3, 4 and 5 to 15, 14, 13, 12 and 11 and 10 using a bus wire, but still it's unclear that pin number 9 goes to which pin. I can show you. Let's say if I use the highlighter tool, click over here, it didn't highlighted any other pin to which it is connected. So in a while I will show you how to make these connections. Let's say I am going to connect these D0, D1 to Control Z. Let's just add a bus wire over here and let's connect these. And let's connect all these together and place it over here. You can go over here and let's just add these. Now we have connected these with the bus wire. Let's just delete this as we are just learning how to use the bus wire. So now you can see that we have added a bus wire that connects from D0 to D13 to the 1 to 9 and similarly 9 to 14 to 10 to 15 pins of the connector. This is just for learning purpose. It's not an actual schematic. We are just learning how to use the bus wire. So the next step is, after we draw a piece of wire, use a add to bus wire entry and route our bus wire, the next thing is we can use add a net label. So let's just click over here. First of all, let me show you. If I click on this highlight tool and click on this, it didn't highlighted any of the other pin to which it is connected. So to make sure that KiCad knows where it should be connected, we need to use this add a net label. Let's say I am going to name it A0 and place it over here. Let's make a copy of this label and let's say I want to connect this pin number 9 to pin number 10 of the connector. Let's just place it over here, hit escape and let me check if it has connected or no. Click on this and click on this. Now you can see that pin number 9 is now connected with the pin number 10. Bus wires also help us for the clarity in the schematic. Like you can see that A0 to A5 performs the same functions and you have just bundled the wire and connected with that particular section of the connector. Similarly, we can connect all the remaining, like A1. Let's place it over here. You can also name it anything, like let's say W1, and hit OK. Let's just make a copy, and I want to connect it with 15, and if I choose highlight, you can click over and you can see that pin number 10 is connected to pin number 15. So in this way you can make your schematic very clear and very clean, and you can add more components on a single sheet. And similarly, let's add more, add net labels. Let's say I want to say A21. You can name any you can name anything to the label. Let's connect this to A3 to A21, copy and just place. I want to place it over here, and let's just see if it is connected or not. You can see over here that A3 or pin 12 of the controller is connected to pin number 13. Now what if I connect this label, control copy and control V to paste it, and I also place this label over here? What will happen now? Now if I check the highlighter tool, then you can see over here that my pin number 15 is also connected to pin number 12, and both are connected to pin number 13. Similarly, if I choose this label on the, let's say over here, then and highlight this W1 net label, you can see this is also connected to this one. Now one thing we have learned, that this is the local label we are using, and local labels connects the circuit on the sheet in which it is being used. But then question arises, why we are going to use the bus wire when we can do this with the help of local labels? The bus wire only helps us to organize and make our circuit a little cleaner and clearer. Like you can see over here, these are the IO pins D0 to D13 that are connected, and you can easily understand that these are directly connected to the connector. Similarly, these are analog pins A0 to A5, these are connected to these pins. Thus it just helps us to grasp the understanding of the schematic very easily, and it also helps us to make our schematic clear and organized in a better way. So this is how you use bus wires. The first thing is you have to place a little piece of wire with the connector with the pins. Then you have to place add a bus wire entry. Then you have to route your add bus, and then the next thing is those pins you want to connect with one another. You need to place this add a net label. So hope you have understood how to use bus wire in your schematic.